So please read through these notes on the pelvic girdle. We already went through the coloring and the 3D model, so you should be able to label some of these parts on a diagram. We now move on to the legs, right? And again, I'm going to switch to the 3D model to show you the various parts. So there is your pelvic girdle once again, and you can see the acetabulum is not visible here because your femur is connected to it, right? So this is called the head of the femur, and it goes right into the acetabulum of your coxal bone to form a ball and socket joint, right? So right here, that is your femur. It's the longest bone of the body, and it's responsible for determining your height, pretty much. At the front, we have two bones, right? We have your shin bone. If you play soccer, you wear a shin pad to protect that bone, right? It's called a tibia, and it's the weight-bearing bone of the lower extremity. And here we have the fibula. The fibula is more for stability, and together they form the lower leg. Over here we see the kneecap. The kneecap is called the patella. Okay, so the bones of the legs include the femur, which is your thigh bone, the patella, your kneecap, your tibia in the medial side, and the fibula on the lateral side. Moving on to your foot, you can see the tibia and the fibula will connect with this bone in the foot to form a stabilized ankle. So let me take away the tibia and the fibula for you to see it clearly. So in the hands, the wrist bones, they are called the carpals, and you have 8 of them. And in the foot, instead of the carpals, we have the tarsals, right? Tarsal. So you have 7 tarsals. 1, 2, 3, 4, 5, 6, and 7. Right? So 7 tarsals, and I actually do want you to know 2 of these. We have the calcaneus here. Right? So the calcaneus makes up your heel, right? Basically, this is your heel bone. And there is another one here called the talus. Okay, Talus. The talus makes your makes the connection with the tibia and the fibula to form your ankle. So these 2 bones, the talus and the calcaneus, they are both part of your tarsals, right? Along with these ones. Okay, so 1, 2, 3, 4, 5, 6, 7. They make up your tarsals. Okay, and over here, right, you have 5 additional bones that kind of forms your the bulk of your feet, and those are called the metatarsals. Okay, metatarsals. Right, and you have a total of 5 metatarsals. Right. And distal to that would be your phalanges, right? So you they are the same name as the finger bones, right? You have a total of 14 phalanges once again, right? So 2 in the big toe, and then 3 for each of the other toes, and that makes up a total of 14 phalanges, right? Phalanges, 14. So those are the bones of your foot. Go back to the PowerPoint here for a second. All right. Again, you can just read this. It's basically what I've been telling you as I described the model to you. Here is the foot, right? You can see the talus, the calcaneus, your heel bone, the other tarsals that you have. So a total of 7 metatarsals, and again, phalanges. Now we will talk about how we classify bones based on shapes as well as joints. So you can classify bones based on shape. For example, a long bone, right? There are various types of long bones in the body. and an example would be humerus, femur, right? So these are examples of long bones. You can have flat bones. Most of them are in the head, right? So parietal bone, temporal bone, right? So these are all considered as flat bones. Short bones would be like the phalanges of the foot. And if it doesn't really fit in other categories, it looks kind of weird, then we call them irregular bones. So that include the vertebrae, right, all of them, sacrum, right? So these are all irregular shape bones. So just know a few examples, right, of each type for the test. Oh, there they are. Okay, I actually listed some examples here for you to see. Joints, there are 3 categories of joints. We have movable joints, we have partially movable joints, and immovable joints. So let's go through movable joint first. Okay, so under movable joints, there are 6 subcategories. I only want you to know a pivot joint, hinge joint, and ball and socket. Okay, the other 3 you don't have to know specific examples of it. So pivot joint allows you to basically move something from side to side, and the best example for that is atlas and axis, right? Your C1 and C2, that allows you to shake the head from side to side. We have a hinge joint, right, such as the elbow joint, right? That is between the humerus and the radius. The knee would be between the femur and the tibia, right? So those would form the hinge joint. Ball and socket at the shoulder, we have the humerus, right, and the glenoid process. Right, at the hip, we have the femur, and the acetabulum. Okay, if you need a refresher of what these mean, just go back to previous videos to see. So just know these 3 types of movable joints for the test. You are going to be okay. This is just a picture to show you the kind of movement produced by each type of joint, right? So for example, C1, C2 here allows you to move sideways, right? And you can see the hinge joint here between the humerus and the radius and the ulna. Oh, I actually made a mistake in the previous slide here. This should be the humerus and the ulna, not the radius. The elbow, right? The elbow is formed by your ulna, not the radius. Sorry about that. And ball and socket, right? The head of humerus in the glenoid cavity. Okay, and then there are a bunch of other ones that I said you don't have to know. Those are a little bit more abstract to see, so we will just omit it for now. Then there are partially movable joints, right? So the ones that we talked about so far, they are movable joints. They actually can create quite a wide range of motion. But now we have these partially movable joints. So they can move, but very, very limited range of motion. Example of partially movable joint would be the joint between your vertebrae, right? So the backbone, there is not a lot of flexibility between each adjacent vertebrae, but collectively, if you take into consideration of the whole spinal column, right, they kind of add up to allow you to bend forward, right? But between 2 backbones, 2 vertebrae, one next to the other, there is not a lot of degree of freedom for movement. Okay, imagine like stacking a bunch of chairs, one on top of the other. Okay, once you stack like 10 or 15 of them, then you can see the whole thing kind of start to bend over, right? but between each individual chairs, there's very little wiggle room, right? And that's what I'm talking about here with the partially movable joints, right? You're not going to be able to move them too much individually, but collectively, it creates a wide range of motions. Finally, we have the immovable joints. These are ones that have been completely ossified, basically, and then you won't be able to move them at all. And it's for good reason, right? The sutures in the skull, you don't want them to have any flexibility in it, right? Because you're protecting the brain, and that's what immovable joints are. You can skip this slide. This talks about the different types of movement, but given the current circumstances, we are going to skip that. Next, we are going to talk about hormonal control related to the calcium level, right? Which in turn relates to your skeletal system. So let me talk you through this first, and then we're going to fill in the hormone chart later on in the workbook. It's important to maintain normal blood calcium level. As you might recall from earlier units, calcium has various functions, including triggering the release of neurotransmitters. So you can imagine if you have too much or too little calcium, then that could lead to irregularities related to neurotransmitter release. It turns out calcium is also needed for muscle contraction. So if you don't have enough calcium, you might have muscle weakness. If you have too much calcium, you might have twitching of the muscle. So the point is you have to have the right amount. You don't want too much, you don't want too little. So to keep calcium level at the right amount, you're gonna have to need two hormones to do that, right? So if you have an increase in blood calcium level, that will trigger your thyroid gland to release calcitonin. Right? So your thyroid gland is kind of where your neck is, right? That's the one that gets big, right? When you don't have enough iodine, for example, you get a goiter, right? So one of the functions of the thyroid gland is to release calcitonin when you have too much calcium in the blood. So calcitonin will do two things to try to bring the calcium level back down. First thing is it will try to deposit the extra calcium in your blood into the bones, right? And secondly, it will tell the kidney to reduce calcium uptake, right? So remember in the kidney, right? In the proximal tubule, distal tubule, collecting duct, these are the locations of the nephron where you will start to reabsorb some of the ions, right? So in the presence of calcitonin, you are basically telling the kidneys to stop doing that, okay? Don't take so much calcium back from the filtrate. We don't need it. We already have quite a bit. Right, so collectively, these actions should bring calcium level back down. On the contrary, if your calcium level is too low, then that will trigger the parathyroid glands to release something called parathyroid hormone, or PTH. The parathyroid glands are these four small glands that are located on the back of your thyroid gland. Right, so this is the front of the thyroid gland. If you turn this around, right, you will see the parathyroid glands on the back. You have four of them. Right, so when there is a drop in calcium level, the parathyroid gland will release PTH. So PTH will try to bring calcium level back up by doing the following things. If you don't have enough calcium, the best place to take it from your body would be from the bone. So it will stimulate calcium to be released from your bones. It will also tell the kidney to increase uptake of calcium. So unlike before, now we want to conserve as much calcium as possible. So we will encourage taking them back from the filtrate so we don't end up peeing them out, basically. And another place you can get calcium is your intestinal tract. So PTH will increase the absorption of calcium from your small intestine, and hopefully these things will increase your calcium level back to normal. So now let's go to the workbook, page 65, and we will label it together. So this is the hormone chart on page 65 of your course pack. So let's look at calcitonin. Calcitonin, the location of secretion for calcitonin is your thyroid gland. Thyroid gland. Right? And the stimulus, the trigger for calcitonin is high calcium level in the blood, or you can say high blood calcium level. Too much calcium, right? So the way I remember it is if there is an increase in calcium, then you will need calcitonin to bring it back down. So there are two things that calcitonin will do to bring the calcium level back down. Number one, calcitonin will increase calcium deposit into bones. Right? So you have a lot of calcium in the blood. Let's put some of those in your bones. Secondly, it will tell the kidney to reduce calcium absorption, right, at the kidneys. Right? So you will just let them stay in the filtrate. You will just remove them from the body through the urine. Okay? On the other hand, we have parathyroid hormone, PTH. As the name suggests, the parathyroid hormone comes from the parathyroid, and that's going to be 4 small glands located on the back of your thyroid gland. And the stimulus, the trigger for PTH would be low blood calcium level. Right? So PTH will try to increase the blood calcium level by taking calcium, right? Taking calcium from bones. Right? It will promote the release of calcium from bones. Number two, it will increase calcium absorption from kidneys and also from the small intestine. Okay, so you can see the effects are opposite, right? So calcitonin and PTH, they are antagonistic hormones, right? The other antagonistic pair that we learned in lecture 9, it was ANH, anti-natriuretic hormone, and aldosterone, and those maintain blood pressure. And here the calcitonin and PTH is another antagonistic pair, and they work against each other to maintain blood calcium level. And so this would be the description for it. And just very quickly, let's take a look at what happens to some common bone diseases. So in osteoporosis, you basically continuously absorb the calcium from the bone. Perhaps you don't have adequate calcium intake in the body, so PTH is going to keep on encouraging your bones to release calcium, and so you can see it becomes very, very fragile, and it could cause you to have a broken hip if you fall on the ground, for example. Here is another one called rickets. And this usually is common in children, and it's caused by a lack of vitamin D. Right? If you go back to a few slides earlier, I forgot to mention this, but PTH, I told you would help the intestine to take up more calcium, but in order for you to do that, you actually have to activate vitamin D first, right? So Typically, vitamin D activation requires sunlight, and if you are kids born in parts of the world where there's not a lot of sunlight, for example, then you might not have enough vitamin D, and therefore, even you have adequate calcium intake, you won't be able to absorb them, and so your bone becomes quite weak. So as these kids grow and they learn, try to walk, for example, the bones of the legs are so fragile they cannot support the weight of the body, and they become bolt-legged like this. So you know, the in Canada, right, the pediatrician association, they actually recommend we taking vitamin D supplements for all babies, right? Even into toddlers age, right? We give them the D drop, for example, to supplement for the lack of sunlight, sometimes particularly in winter. And that is it for the skeletal system.